So let's get some more practice with implicit differentiation. And in this case, we're just going to find the derivative function. We're not going to actually find the slope of the line at any given point. So this just gives us some practice with the implicit differentiation here. So I want to find dy dx here. So I'm going to take the derivative with respect to x of both sides. Okay, so I get this. And so now I need to use the product rule here. And in doing that, I'm going to get the following. The derivative of the first function is 2 times the second function plus the first function times the derivative of the second function. The second function being just y as a function of x. Then I need to use implicit differentiation here, so that would be 2y dy dx. So it would look like that. And then here, I'm going to take the derivative of the first function of both terms, so that would just be 1 here with respect to x. X with respect to x is 1. And then this would just be dy dx. Okay, so now I'll bring everything with a dy dx to this side and everything without 1 to the other side. So this would be like 2x dy dx plus 2y dy dx, and then moving that to the other side gives me minus dy dx. And then over here I just well, I have the 1, but I'm going to move this 2y over to the other side. So minus 2y. Okay. So now I'm going to factor out the dy dx here. And when I do, so this goes up here, I get dy dx. And then over here I just have 2x plus 2y minus 1. And all this is equal to 1 minus 2y. So this is dy dx times that, so I divide both sides by that. And then I get dy dx is equal to 1 minus 2y all over 2x plus 2y minus 1. Okay, so that would be the first one there. So now, let's try this one. This has a trig function here. This is going to use the product rule there. So now I'm going to take the derivative with respect to x of both sides. So we get x to the 4th plus sine of y. And then this would be derivative with respect to x of x cubed y squared. So here, taking the derivative of the two terms, the first one I get 4x cubed. And then taking the derivative of this, I'm treating the outside function as sine of something, and inside that something is y. So the derivative of the outside function is cosine evaluated at the inside function, which is y, times the derivative of the inside function, which is dy dx. So it would look like that. Now for this one I need to use the product rule. So the derivative of the first function times the second function, and then plus the first function, x cubed, times the derivative of the second function, which is going to be 2y, and then I need the dy dx for the implicit differentiation. So now I need to bring everything with the dy dx to one side, and so I'm going to get cosine y dy dx. And I'm going to bring this over, minus x cubed 2y dy dx. And then this will be the 3x squared y squared, but then I'm going to move that over, minus 4x cubed. So it would look like this. Then I could distribute the dy dx out. and then I'm left with just cosine y minus x cubed 2y. And then I'm going to divide both sides by that, and that gives me dy dx is equal to all over cosine y. So there you go. You can see that these kind of follow the same pattern each time, and they can get pretty complicated, the final expression here, but the pattern is taking the derivative of both sides, moving everything with the dy dx to one side and everything without one to the other side, factoring out the dy dx and dividing by what remains. Okay, so common pattern there. So let's try this one. Now this wants us to find dr d theta, so the rate of change of r with respect to the theta. So I'm going to take d theta of cosine of r plus cotangent of theta, and then d theta of just r. Okay, so now treating cosine as the outside function, r of theta as the inside function, r is an implicit function of theta, and so the derivative of the outside function of cosine would be opposite of sine, evaluated at the inside function, which is r, times the derivative of the inside function, in this case dr d theta, the derivative of r with respect to theta. And then this here would be just a regular, this is d theta of cotangent of theta, so I'm just using the rule for cotangent of theta, and if you go back and look, the derivative of cotangent was the opposite of the cosecant squared of theta, so it would look like that. And then d theta of r is just dr d theta, so it would look like that. And so now I want to get everything with the dr d theta to one side, so I'm going to move the sign over here, and I'll write it like this over here, the dr d theta plus sine r dr d theta, and this is equal to the, so what I did is I moved this to the other side, but then I flipped the whole thing around, opposite of cosecant squared theta. Okay, so then I can factor out the dr d theta, and then I'm left with just 1 plus sine of r, and that's equal to the opposite of the cosecant squared theta. Then I get this by itself by dividing both sides by the 1 plus sine r. So 1 plus sine of r. So there you go. dr d theta is equal to that. Okay. So now in this final one, what it wants me to do is find the second derivative of y with respect to x. So what I'm going to do is I'm going to find the first derivative, and then I'm going to take the derivative of both sides. Okay. So first, finding the first derivative. Or when I say I'm going to take the, not the derivative of both sides, I'm going to take the derivative of the derivative. You'll see. So taking the derivative of this side, and I'll write that as y to the 1/2, and the derivative of this side. So taking the derivative here, this will be like the product rule, and so what I'll get here is I take the derivative of x, which is 1, times y, so it'd be like just y, plus x times the derivative of y, and so that would be x dy dx, so it would look like that. And so that's the product rule on this, and then plus, now I'm going to take the derivative of y to the 1/2. So I'm going to bring down the 1/2, here, and then y to the negative 1/2, but then I got to take the derivative of the inside function, which is dy dx. So that's all of this. Now this is just equal to 0. Okay? So now what I'm going to do is I'm going to bring the y to the other side here. And so when I do that, I'm going to get this. So I'll get, and maybe what I'll do is I'll factor out the dy dx as well. Dy dx, this will just be x plus 1/2 y to the negative 1/2. So it look like that. And then I'm moving that y to the other side, so that's just negative y. So it would look like this, and then I'm divide both sides. Dy dx is equal to the opposite of y over x plus 1/2 y to the negative 1/2. And right now I'm going to just leave it like that, because what I need to do now is find the derivative of this. So this would be like d dx of dy dx. So that's like taking the derivative of this side and the derivative of that side. So d dx of all of this. Okay, now this is just that d squared y. So this would be d squared y over dx squared. So that's the symbol for the second derivative. And now I'm going to take the derivative of that. So now, for this, I'm going to need to use the quotient rule. So for this here, that's just going to be, it's the derivative of the top, which is the opposite of dy dx. Okay, so times this, so x plus 1/2 y to the negative 1/2 minus this negative y. So that negative y, it'll be this times the derivative of that. So the negative y will make that a plus, so y times the derivative of this. So that'll just be 1 plus, this will be, bring down the negative 1/2, and I get negative, this will be negative 1/4, and that'll be y, and then subtract 1 from that gives me negative 3/2, and then times dy dx. So it's like all of that, look at that, all over the bottom squared. So x plus 1/2 y to the negative 1/2 squared. Okay, so now here's the clincher, and I'm not going to simplify here. We have a dy dx, so to get it all in terms of y and x, you have to put this in every time you have a dy dx over here. So let's see if I can do that. I'm sorry I had to squeeze it all in over there, but hopefully now I got some room here. So this is opposite of dy dx. That'll take care of that negative sign. So I have y over x plus 1/2 y to the negative 1/2. Okay, that's in for this. And then I have times all this. X plus 1/2 y to the negative 1/2. So this would look like that, and I think that's actually going to cancel each other out there in a minute, but let's finish here. So this will be plus y, and then this will be that was a negative 1/4, I think. So this is 1 minus 1/4 y to the negative 3/2. And then you have a dy dx. So then you have to put this all in there. Negative y over x plus 1/2 y to the negative 1/2. and I am sorry, I'm running out of room here, but then all of this over x plus 1/2 y to the negative 1/2, that squared. Okay, and then, and I know I had to squeeze that out, so maybe I'll do one more step here just so I can do some simplifying, because I think this cancels that out, leaving me with just a y. So I get the following. I'll just have a y plus a y, and then that'll be, I'll just write it like this. So I wouldn't, unless you know for sure, like I wouldn't try to cancel things out here. It's very complicated. You have to have a factor. They have to be common factors to cancel out. So just because you got this y here and this one down there doesn't mean that's going to cancel out. And in fact, I don't think there's any cancellation there. But this would be this. So I don't know if I would do extra extra simplification, especially if what you want to do is find the slope, because then you just need to put in x and y and calculate the slope. But there's a few things, like you could put this up here on that, you could put this on that or whatever, but I would just leave it like that. It's complicated. You can see that they get very complicated. Imagine taking the third derivative. It would be the derivative of that. Fortunately, you're not ever asked to do a third derivative on the homework.